Good day, everyone. Hope you all are having a wonderful Christmas season here in 2024. Today we are going to be talking about one of nature's most destructive but beautiful phenomenon, nebulae. Space is vast and is what could be called a mysterious playground of physics.
Nebulae tell a more interesting story beyond what is seen in telescopes today. With rich histories and stunning space photos, they are popular today even among casual non-space enthusiasts.
We'll be starting from its earliest discoveries embedded in our planet's history, all the way up to today. Has anyone observed them in the past? And if so, what did they conclude then that could be compared to what we know today?
Then, we'll discuss how we were able to observe all kinds of nebulae in space. We'll be answering how humanity accomplished this and how far we've come with technology up to 2024.
Then finally, we'll be discussing how having these images and informative technology and knowledge impacts us today. What impacts have these photos in space had on the public, and how do these images help astronomers/scientists on Earth draw more conclusive scientific evidence? Today, all will be answered.
We'll be starting from the earliest of discoveries embedded in our planet's history, all the way to present day. Additionally, we'll be taking a deep dive into what we thought about nebulas in the past and compare it to what we know today. Have you ever looked up at the night sky and wondered about those faint, cloudy patches scattered amongst the stars? Well, I haven't, because light pollution is annoying and prevents us from seeing lots of the natural celestial artwork that our universe provides. However, if you could see them, they are likely nebulas, which are massive clouds of gas and dust floating in the vastness of space. But they're not just cosmic fluff. Nebulas are some of the most important building blocks of our universe, and their story is as fascinating as the stars they create. Let us start with the basics. The word nebula comes from the Latin meaning cloud, and that's essentially what they are, gigantic clouds made up of hydrogen, helium, and other ionized gases. But they're not all the same. Some nebulas, like the Orion Nebula, are stellar nurseries, places where new stars are born, while others, like the Crab Nebula, are remnants of supernova, marking the dramatic deaths of stars. Astronomers have been observing nebulas for centuries. In fact, one of the earliest recorded observations of a nebula was made by French astronomer Charles Messier in 1758, when he identified the Crab Nebula. For the longest time, astronomers thought all nebulas were just distant clouds in our own galaxy. It wasn't until the 20th century that we realized some of these clouds were actually entire galaxies themselves. Talk about a perspective shift. As telescopes improved, so too did our understanding of nebulas. During that same time, in 1758, Charles Messier cataloged nebulas he found to help comet hunters avoid confusing them with comets. This catalog, known as the Messier Catalog, became a cornerstone for deep sky observation. Fast forward to present day, and we've got the Hubble and James Webb Space Telescopes, just to name a few, delivering us jaw-dropping images of nebulas like the pillars of creation. So why do nebulas matter? Well, they're not just pretty to look at, they're the birthplaces and graveyards of stars. The elements in nebulas eventually form stars, planets, and ultimately us. That's right, the carbon, oxygen, and other elements in your body were once part of a nebula. Nebulas are a reminder of the universe's beauty, complexity, and interconnectedness. They tell a story of creation and transformation stretching across billions of years. And who knows, maybe one day we'll uncover even more secrets hidden within those celestial clouds.
As Eric said, nebulas remind us of the universe's beauty and complexity. They do tell a story of creation and transformation, but have you ever wondered how humans could recreate such beautiful images of them? Ancient civilizations likely observed the first nebulae with the naked eye. Many cultures, including Persians, Chinese, and Native Americans, have records of observing fuzzy objects. However, the telescope's invention in the 17th century revolutionized our understanding of nebulae. Nicholas Cloud is often credited by discovering the Orion Nebula in 1610. Later, Christian Huygens provided a more detailed description of the Orion Nebula, recognizing its true nature and celestial cloud. The 18th and 19th centuries saw significant advancements in our understanding of these cosmic clouds, leading to the realization that they were not just distant star clusters, but vast clouds of gas and dust. Currently, astrophotographers employ various techniques to capture this cosmic masterpiece. One technique is narrowband imaging. Using specialized filters, we can isolate specific wavelengths of light, revealing hidden details and vibrant colors our eyes cannot perceive. This technique is particularly effective for nebulae that emit their light. In contrast, broadband imaging captures lights across broader spectrum, often in RGB channels. This technique is ideal for reflection nebulae, which reflect the light of nearby stars. Once captured, these images undergo meticulous post-processing filtering by assigning specific colors to each spectral band and blending them together. We can create stunning full-color images. The choice of equipment is also crucial. A fast lens with a low focal ratio is ideal for gathering more light, resulting in more transparent images. A focal length between 135mm and 350mm is often sufficient for nebulae. Modern DSLR cameras offer excellent performance, but dedicated astronomical cameras with higher sensitivity and lower noise are becoming increasingly popular. Even smartphone cameras can capture stunning night sky images with a telescope adapter. The appearance of a nebula can vary depending on the technique used. Long exposure images can reveal vast colorful nebulae stretching across the sky. Through a telescope eyepiece, they may appear more subtle ghostly. Dark nebulae appear as shadowy voids in the night sky, while bright nebulae emit a faint, almost like an ethereal glow.
With us approaching a more sophisticated technological world in 2024, we were able to get absolutely stunning photos from NASA telescopes into public eyes and give nebulae the attention they deserve. But why is it important that we spend insurmountable amounts of money on science to get these types of images? This data we get from outer space and nebulae has shown to offer more than just scientific evidence. There are many famous nebulae among curious learners and space enthusiasts due to how stunning they look in images. Some include the Crab Nebula, the Carina Nebula, and the Helix Nebula. The nebulae in these images get their colors and hue from the different gases and materials slowly dispersing over them over time, which creates a gradient-like effect when capturing images. One of the features astronomers look at is the change in colors to depict materials and their densities from telescope photos. This unique effect we see in photos is when a star with a core mass less than 8 times our Sun's becomes a nebula. It loses its ability to perform nuclei fusion after a long period of time, and the star will begin to shed its outer layer, remain slowly in patterns. So slow, in fact, that it could take tens of thousands of years to see this process finish. Although this process has made it difficult for current-day astronomers to keep informative data tracking on the life cycle of the specific phenomenon, it serves to create a natural but refined artistic effect that we can awe. We briefly described how the color of the telescope pictures can help differentiate material coming out of the nebula, but there is more that can be depicted from these celestial bodies that could further scientific knowledge. For example, another thing astronomers analyze is the type of material emanating from the nebula, such as carbon and nitrogen, in addition to the density of the nebula's core. Having this can help draw more conclusive evidence as to what happened while the nebula was more alive, as a star performing nuclei fusion. And this is huge. If you ask any scientist, it is a whole lot better to provide insights and predictive analytics about how fast a nebula expands rather than just sitting around for thousands of years. Moreover, this data can help explain how long a star can live while it is in any step of its life cycle. Nebulae are truly phenomenal in every aspect. They are beautiful, have lived long telling lives. It can provide useful scientific feedback about a star's life cycle. And please check out NASA's website for more photos and information.